Okay, so please, Carol, I haven't introduced you, so you're going to have to say where you're from, and then please tell us about the project.
Thank you. Is that working?
Is it? Try it again.
Oh,
Yeah, it's working.
Okay.
Yep.
I'm Carol Flannagan. I'm from the University of Michigan, but I'm here in Gothenburg working with people at Chalmers and SAFER through a Marie Curie incoming grant, so I'm actually spending quite a bit of time. And the first two projects, apparently I got elected as the spokesperson for our projects, but we picked them specifically because they are collaborations. They're funded research that I'm working with colleagues here, and so they're actually quite exciting in that way. And they have a bit of a theme. So my background is in statistics, which is why it will start looking like statistics people are doing it. So the first one is sponsored by the Auto Alliance, which is essentially the trade organization for car manufacturers, mostly US, but not entirely. And essentially what we're looking at is distraction and crash risk. But the kind of theme that I get at is it has a statistics component, a pure methods development component on big data, and then also let's answer some questions component which have to do with the effects of distraction on crash risk. So.
Great. Well, I'm also failing with the clicker now, but. Okay, I can press.
Well, this is it. So.
That's the first one, yeah? And the second one is this one. Yep.
Yep. So it looks kind of, I made both the slides. So, so this one is actually funded by the government, so the U.S. Department of Transportation. It is also working with sort of big transportation data and particularly driving data. In fact, it's working with basically the same very large data set. And again, we're working on developing statistical methods that will help us move forward on answering a lot of different questions. But then we simultaneously work on a specific question, which in the context of this project is trying to understand how to do a better job at safety in work zones by understanding how measuring normal driving tells us about what is not normal. So not normal in this case meaning unsafe. So those are the themes.
That's great. And it's very difficult to summarize some things like this in this time. So this information will be sent around, and I think it's also a really interesting example of how we're trying to work collaboratively in different areas, but not just inside, not just in Gothenburg, but with other colleagues as well. So thanks a lot, Carol, for presenting that. Okay, Sonia, you're going to tell us about the next project.
Thank you. So I'm Sonia Ye. I'm from the Department of Space, Earth, and Environment. I'm a professor in Energy and Transport Systems. And in my group, in collaboration with the Computer Science Department and the Big Data Group, I'm presenting 3 projects that we're trying to combine big data, machine learning, and computer simulation model to understand the transition to future mobility. So the first project we collect Twitter data, trying to understand the humans' mobility patterns, where we are, how we travel, how much we travel, how do we travel. We look at it at the individual level, at city and national level. The second project is to collect HERE data, try to understand the conditions of travel congestions and its association with accidents and incidents. What are the conditions that lead to high congestions and abnormal congestions and high delays, and what are the incidences that lead to smaller delays, and how do we propose mitigation strategies to reduce the possibility of delay. And the third project is to build synthetic Sweden, to create computer simulations model and synthetic population to understand the infrastructure demand if we have, for example, a shared autonomous electric vehicles. We can look at these 3 separately or look at them together. What should be the infrastructure transition look like? And what if we have behavior changes? How would that change the system? How would that affect the infrastructure demand during the transitions?
Okay, that's great, and very interesting to again to bring back us to remind us about the transport and energy connection, which Maria told us about when she introduced the whole day. So we can go to the next one, and I think Mats, this is yours, yeah.
Hi, Mats Johansson, professor in logistics at Chalmers. The development we see in electrification and autonomous vehicles lead to the use of new materials and combination of new materials in the vehicles for the purpose of lower weight and functionality of the vehicles. So, do we know which materials will be used? Do we know the volumes of these? and do we know how to take care of it after its use in the vehicle? It's not only that we need to know the efficient recycling processes to apply, we also need to understand the rather complex system of activities and actors and materials flow in the system. So we need to get hold of the material in a secure and efficient way in the materials flow. So there are very materials flow that you are looking for, aiming for, but certainly also a lot of flows that you are not willing to have for security reason, for example. So to form a roadmap for research and guide industry, this project has been formed jointly between researchers from industrial materials recycling at chemical engineering and researchers in logistics and supply chain management, technology management and economics. The starting point is 2 projects we are running now separately. They are about to finish within the area of recycling system for lithium-ion batteries. We will then go to another type of material, which is glass. Glass is not the same type of glass as in the old-fashioned windshields we know from our first cars in life. Much more complex and much more combined materials than these. So from these 2 detailed examples, we will scan what will happen in the materials, in the development, and assess these materials from a recycling process and from a supply chain point of view to have like a research roadmap and also some guidance to industry.
Okay, thank you. And also very interesting because we talked a lot about flows on transport, and Stefan Bach mentioned where were the trucks in the network this morning, but I guess it's also interesting to think about the logistics behind these trucks and these flows. So this project's bringing together a whole different set of expertise to have a look at that. Okay, we're going to go to Martin, and if you would just summarize this project that you're involved in.
So I'm Martin Emanuel. I'm doing a pre-study at the Chalmers new division of STS, Science, Technology and Society. And I'd like you to imagine that you're walking down the street of Linnégatan with smartphone in hand. And you're going to be able to see how did this street actually change and develop during 100 years. I mean, what did it look like? What did the traffic flows in this street look like? How did they change? And how did politicians, planners, and other kind of users of the street, how did they discuss the street and how it needed to change? So this is what our pre-study is about. I mean, trying to set up a digital platform and connect it to a smartphone and to be able to explore the street. So the pre-study is basically about trying to find what kind of materials can we use to present this full picture of the changes of a street. I mean, quantitative data, sort of traffic flow in Linnégatan in this case. Images, of course, I mean, how did the appearance of the street change? But then also, I mean, the archive materials that we as historians are used to work with, capturing planning processes, policy processes, and so on. Well, maybe you ask also, so what's the point of this? What can we actually use this for? What's the point? And I think as a historian, I'm keen to see, well, I firmly believe that in order to be able to move forward in a useful way, somehow we need to understand where we come from. That's basic somehow. But I also, in this case, I also believe that by looking back, we can see other kinds of uses of the street than the current ones. It can we can use our imagination also to look forward, to be able to sort of envision more sustainable uses of the street. Of course, in the past we had more sustainable uses, but we will not be able to move backwards possibly. But still, it unlocks our imagination, I think, and it also shows or gives us an understanding about these processes that needs to happen in order to create a more sustainable future.
Okay,
thank you.
Thank you. And I think it's very interesting because a colleague of yours, is it Patrick Hofsmad, who's in the architects department? He wrote an interesting blog about the perception of Linnegarten when some of the buildings were constructed, which had a lot of negative comments about buildings, which people now look at and see as being very attractive. So I think very interesting. You just happened to pick a street that he'd written about, but thanks. Okay, and Yvonne, to close the discussion for this part of the session.
My name is Yvonne Sanchez-Diaz. I'm from Chalmers University of Technology. And the title of our project is Autonomous and Connected Trucks for Electric Distribution. And here you can see the faces of the researchers involved in the project. Maybe at least a couple of them should be familiar to you. The researchers come from the Electrical Engineering Department at Chalmers. We also have two researchers from the Industrial and Financial Management and Logistics from University of Gothenburg, and two more, including myself, in the Logistics and Service Management Division at Chalmers from the Technology Management and Economics Department. And the purpose of our project is to integrate basically these different disciplines, these different perspectives, to study the problem of the vehicle and the systems for freight transportation of the future, which we think will incorporate some features such as being autonomous or automated at some level, being connected, and being electric, or using electric energy. And then the focus will be on two different types of vehicles. We will focus first on a medium-duty truck, which will be operating from a distribution center to the urban environment. But we will also focus on smaller vehicles that will operate within large traffic generators. These large traffic generators could be either malls or, in our case, we're going to focus at Chalmers as a campus because we know Chalmers generates a lot of freight traffic. So what will happen when the deliveries get to Chalmers? Can they be distributed through autonomous smaller vehicles within the campus? So that is going to be another focus of our project. And the dates for the project are going to be 2018 and 19. This is funded by the Area of Advance, and hopefully in a couple of years we can show more results on this.
Okay. Thanks a lot to everybody for presenting it. Thanks very much.